Alrighty, folks, so this is our last equation solving specific lesson. It has to do with equations and fractions. So this is definitely getting into like the 5-star level equation solving questions. So if you haven't done, which one's this? This is lesson 6. If you haven't really spent a lot of time with lessons 4 and 5, the x on both sides or the simplify first lessons, definitely spend some time dig into those ones before coming to this one. And if you're really struggling with those ones, then I would say put this one on the back burner because it's only going to be that 1 or 2 questions near the end of the test. So just if you're pushing for kind of the 100% on the test. So nothing like it's one more step, just like every other lesson, sort of one more step than the one before it. It's not anything groundbreaking, but definitely work on those base skills before you get to this one is all I'm saying. So how I handle equations with fractions is I quickly get rid of the fractions as fast as I can. So I have one step, and after that one step, the equation, no matter how many fractions are in it to start out, the equation will not have fractions after this one step. And so how it works is a little bit of magic. So I'm going to take these fractions and I'm going to multiply them all by 12. And not by 12 top and bottom, I mean the whole number 12. So I'm going to multiply each of them by 12 over 1. And so when you do that, multiplying fractions the easy thing. You do top times top, bottom times bottom. So I'm going to get 24 over 3. I'm going to get 12 over 4. I'm going to get 60 over 6. And I'm going to get, again, 60 over 2. So now you might think, big deal, what's Mr. Clement doing here? Well, 24 divided by 3 is not a fraction. 24 divided by 3 is the whole number 8. 12 divided by 4 is the whole number 3. 60 divided by 6 is the whole number 10. 60 divided by 2 is the whole number 30. So I took 4 different fractions. I multiplied them each by the same thing, and then all of a sudden I didn't have fractions anymore. So now the question is, how did I come up with this magic number 12? Well, the key thing is this will always work if your number that you're multiplying them all by is a number that all the denominators go into. So 3 goes into 12, 4 goes into 12, 6 goes into 12, and 2 goes into 12. So really what you're trying to find is a common multiple for all your denominators. Ideally, you find the lowest common multiple, or common, like it would be the number that would be the common denominator, but you're trying to find any of them would work. So this would also work if I multiplied them all by 24. I would have got 16, 6, 20, and 60. I still would have got whole numbers. The smallest number just gives you smaller numbers to work with. Now, how we employ that is equations. You're allowed to do things to both sides of the equations, and it's not going to change the answer. Because really, this is saying that this number has to be the same as that number. And they're just numbers at the end of the day. So if I take those numbers and I multiply them both by the same thing, they're still going to be equal to each other. The equation's still going to work. And what I would multiply both of these numbers by, well, is a number that the denominators both go into. So I look at 3 and I look at 5, and I'm going to say, well, my magic number is 15. If I multiply both sides of these equations by 15, then I shouldn't have any more fractions. So, and I'll put it in brackets. You have to multiply the entire side by 15. That 15 is going to distribute into both things here. So I'm going to do 15. Think of it as 15 over 1 when you're doing the fractions. 15 times x is 15x. Don't lose your x. And then 1 times 3 is still 3. And then minus, I don't have to think of it as a fraction when I multiply by 2. 15 times 2 is 30. Equals, again, this side's a fraction, I'll think of it as 15 over 1. 15 times 3x is 45x. And then 1 times 5 is 5. And if you look at it, those aren't fractions anymore. I can do 15 divided by 3 and get the whole number 5. I have 5x here minus 30 equals 9x. And we're back to an equation that we were looking at yesterday. So I've got x on both sides. I'm going to get rid of one of the x terms. I'm going to get rid of this 5x here so that I have just x on one side. That's going to leave negative 30. Don't drop that negative sign. And that's going to leave positive 4x. Divide by the number in front of x. I get x equals, it's negative 30 over 4. You can totally leave the answer like that. It's not a whole number, so you can leave it as a fraction. Kind of makes sense. There's fractions in the question. We can have a fraction as our answer. We're done there. You can reduce that to 15 over 2 if you want, but you don't have to. So, same deal. So you can pause the video, see if you can come up with the magic number that's going to get rid of these two fractions, and then see if you can do the steps where you multiply both sides by that magic number. And now you've unpaused. You did great, didn't you? You did awesome. I believe in you. 3 and 2 are the denominators. You're going to multiply everything by 6. So I'm going to get 6 times x is 6x. The 2 stays on the bottom because we're thinking of it as 6 over 1. And then don't forget to multiply. Even though that one's not a fraction, everything's got to get multiplied by 6. So there we have it. And then we're going to get 24 over 3 when I multiply 4 over 3 by 6 over 1. Then do your division. 6 divided by 2 is the whole number 3. And then 24 over 3 is 8. And we've seen this type 100 times. Get rid of that 6. To get the x by itself, divide by the 3. And again, I get a fraction for my answer, but that's not a big deal. 14 over 3 is my final answer there. Okay, 2 more here for you to look at. So again, you can pause and see if you can give those ones a whirl. I guess I should leave that up on the screen for a second so you can pause and look at that. So you can pause here, take a run at these two, and then unpause and see what I do with them. Okay, so 4, 6, 2, and 3, that's just like the example I was showing you at the top. A number that 4, 6, 2, and 3 all go into. 12 works. 24 would also work. But 12 is the lowest number that those all go into. So I'm going to multiply both sides by 12. And since they're all fractions, I'm going to think of it as 12 over 1 for each of them. 12 times z is 12z over 4. 12 times 5 is 60 over 6. 36 over 2. And 12z over 3. So the biggest mistake I see on questions like this, people get that magic number, they start leaving out the terms that have variables. They might drop that z there and it's just 12 over 3 all of a sudden. Whatever terms have a z or an x or whatever the letter is to start out, those terms will still have a letter after you've done this trick to get rid of the fractions. And then I look, 12 divided by 4 gives me 3. That one's got a letter, so it keeps its letter. 60 divided by 6 is 10. 36 divided by 2 is 18. And 12 divided by 3 is 4. There we go. Now we're looking at something that we were solving yesterday. We've got x on both sides. You got to get rid of one of the x's first. I'm going to get rid of that 4z first. I'm going to get rid of the negative one so that I end up with a positive amount of z's. 7z plus 10 is 18. Get rid of the 10 next would be the pattern that we've been following along to get the z term by itself. You're going to be left with 8 there. Divide by 7. Divide by 7. Z is 8 over 7. And this last one, again, the only things that matter are the denominators. The denominators are the things that make it fractions, right? So I don't care that that's a 5. I don't care that there's a 3 there. What I'm looking at are this, that's a bad zoom. This 3 here and this 4 here, my two denominators. The number that those both go into, again, is 12. So I'm going to multiply everything by 12, even the non-fractions. So I'm going to do 12 times the 5x and get 60x. 12 over 1 times 1 over 3 is 12 over 3 equals 12 times 3 is 36. 12 over 1 times 3x over 4 is 36. That term has an x. Keep it there. Divide by 4. Then do your division so that they're not fractions anymore. 60x minus 4 equals 36 plus 9x. Now we've got a regular x on both sides equation. Get rid of one of the x's to start out. So I'm going to subtract the 9x so that I get a positive 51x. Add the 4 to get the x term by itself. Divide by 51, divide by 51, and you get x is 40 over 51. I don't think that reduces offhand. Doesn't matter, we can leave it like that. And that's what I would do with that one. Okay, so skill check, solve these on your own on the second page. So what we have here is 3 equations here for you to work in on your own. See if you can do it all. You can see that it's a bit of everything that we're doing, yesterday's lessons and today's lesson. So again, I would pause, actually try these on your own, just don't watch me do it. And then I will talk through them just so that you have a video record of if you get stuck on one of them. And then after that, the practice that I have attached to this lesson, again, it's a mix of all sorts of different types of equations. So a lot of equations that look like you were working on yesterday. And then the fractiony ones don't actually pop up till the very end of that practice. There's just a few fractiony ones on that one. Okay, so you've tried these on your own. I'm going to work through them now. Plus 3, sorry. So I'm going to combine like terms on the right side because it had more than 2 terms. So 3x plus 1x is 4x, negative 2 and positive 5 is 3. Now I've got an equation with x on both sides. I'm going to get rid of one of the x terms first. Then get the x term by itself by getting rid of that plus 6. I got 3x equals negative 3. Divide by 3, divide by 3. X is negative 1, and that one is what you should have got. Now I'll just point out like how quickly I'm getting through these and how kind of automatic it is. So really, this skill, equation solving, it's all about recognizing the patterns and realizing that it's always the same steps over and over if you've got that flow. Get it down to 2 terms on each side by simplifying first, like we were doing yesterday. Get rid of the x on one term, then get on the one side, sorry, get rid of the get the x term by itself by getting rid of the non-x term, and then divide by the number in front of x. I've got those steps down pat because I've solved tens of thousands of equations in my life. I've put in my 10,000 hours of practice, as Malcolm Gladwell would call it. And how you got to get to that stage, I don't expect any of you this year to be at the level that I'm working at, obviously, but how you get there is you put in the practice. So that's what this is all about, just putting in the practice, getting in those repetitions so that you start to see the pattern so that you can go through these steps kind of on autopilot. Okay, I'm looking at this one. We're simplifying first. So here we go. I'm starting with the right side because it's a bit easier actually. 4 times x is 4x. 4 times negative 2 is 8. Sorry, negative 8. And then there's a plus 1. That side's not quite simplified yet because the negative 8 and the positive 1 can go together to make negative 7. That side's simplified. The other side, it's a bit trickier. It doesn't quite look the same. What you need to see is this side here does not say 4 times that bracket. If it was this 4 times this bracket, then the 4 would be mushed right up beside the bracket like it is there. That doesn't say that. It says 4 and then minus the bracket. So 4 minus the bracket. Well, what is that number? Just like what's the number in front of that x? That x in the brackets is 1x. That number in front of the brackets is actually a minus 1. You can think of it as. So the 4's got nothing to do with the multiplication. It stays there. We're doing negative 1 times x is negative x, and then negative 1 times 6 is negative 6. Negative x, 4 minus 6 is negative 2. There we go. There's my terms combined. Now I can go into my solving for x. So I got to get rid of the x's from one side. I'm going to get rid of the negative x so that I'm left with a positive amount of x's. Doesn't matter, I could have got rid of the 4x as well. Then you get rid of that negative 7 by adding 7. I get 5, negative 2 plus 7 is 5 equals 5x on its own. Divide both sides by the 5, and you get x is positive 1 on that one. All right, one more mountain to climb. These equations here, 4x over 3, I've got fractions in it, so I'm going to put brackets around both sides. I'm going to find my magic number, which is the number that the denominators both go into, which is 12 with 4 and 3. I was feeling really creative with my denominators on this. So I'm going to get 48x over 3. I'm going to get 12 times 3 is 36, and 12 times negative 7 is, that's going to test me, 784. Yeah? 84x. I'm asking you as if you can answer, but I'm in the past right now and you're in the future. Okay. Whew. And then 12 times 2 is 24 on the other side, and over 1, so keep it as over 4. 48 divided by 3 is 16x. The term has an x. Minus 36 minus 84x equals 6. So do your division there. Now, my x terms are on the same side of the equation, so I'm not thinking of getting rid of one of them. I'm thinking of combining them. So I've got to do 16 take away 84. Man, I'm wishing I packed my calculator, but that is 68, negative 68. X minus 36 equals 6. Okay. I'm going to add 36 to get the x term by itself. 36, is 42. And then divide by the negative 68. So it's a negative number in front of the x, so you divide by that negative number. And I get a fraction. It's a negative fraction. I always put my negatives on top of the fraction. It's a bit more clear. You're less likely to make mistakes if you move that up. Remember, a positive divided by a negative is negative, same as a negative divided by a positive. So it doesn't matter where that negative is. I like them on top. And again, you can leave it as the 42 over 68. You can reduce it to, what would that be, 21 over 34 to start out. And then 3 and 7. Yep, so I think that's as far as you can go with that one. Whew. All right. Oh, geez. I'm at 18 minutes recording. I apologize. This is a longer video than I normally make. But I will. So your job, work on as much of this practice again, like I said. Work on as much of it as you can. It's a mix of everything we've done with equation solvings, and I'm going to post answers to that practice as well. And you can reach out to me and get me to check over any work or ask me for help on any of the ones that you're getting stuck on. Okay?